That's because I paused and then you paused. What we're gonna do is we're gonna jump off from our understanding now. I know that we were still working with some whiteboards the other day, but I think that we were zeroing in on our understanding of what's going on. Okay? And we talked about it yesterday. I know that many of you weren't here. I understand that. But in the end, what we found, okay?
A bag of notes. Anybody wrote down?
Whoa, why is it black?
Oh my
God. You know what? That hurt my eyes. Actually, you know what? Mr. Pata,
What?
this actually makes the whole color thing better. Like, I can see the colors better. You know what I mean? Like, us colorblind
That was the
fellas.
last day in the notebook. Do you know about? Grace, what is it? Grace. Grace? We've been working on Grace.
Alright. Gentlemen, ladies, refocus please. So,
Why is it glass?
this is the conclusion. Now, this is the conclusion from the lab. We were right there on Friday. I don't think we got quite to the conclusion, but I think you guys were there. That if you look at the total momentum, there's the momentum of all of your objects before the event, bouncy collision, sticky collision, explosion, it has to equal the total momentum after.
What the heck?
Okay?
Yeah.
Now, I will tell you that this actually is not a small deal. Okay? This is not a small deal. It's such a big deal. I can tell that's great. Really? I can tell that's great. Right? That's green, right? Yeah.
See? The black is better.
So, this is such a big deal that it is actually a law that you guys were developing from your labs. That no matter what happens, the total momentum before is equal to the total momentum after. This is called the law of conservation of momentum. If you add up all the momentums of your objects before, they have to equal all the momentums of your objects after. Okay? You guys got this? Alright, so open up your lab notebooks because I'm going to give you the problem-solving structure, the external structure we're going to use. Alright, so open up your lab notebooks real quick. Yeah. You should already have it.
So we already did this yesterday.
Hey, ever since ever since
They were so much easier the upper.
I just didn't know. Well, I mean, yeah, I don't know.
yeah, I don't know where I was on radio. Hey, can we play a song?
No.
It's the same one. That was smart. Is that purple?
No, it's blue.
That's blue? Doesn't that look purple to you? Actually, that looks good on it.
No, it's just like a darker blue.
See, it makes the ID
All the ready to
Alright,
pick.
ready? So, we're going to practice on the sheet that's called Homework 2 today. And we're going to use this problem-solving structure for all of them, where you have a before side and an after side. This is the picture, so you draw the picture of whatever's happening before the event.
Yep.
Then you draw the picture of whatever's happening after the event. The system, inside this circle, you're going to write whatever you're considering to maybe have momentum. You're going to write that in here. And then this is it's called a momentum bar chart. We're going to draw bars on this to represent the momentum. Okay? Now, we're going to employ this idea.
That was great.
We're going to employ this idea where if we
Whoa.
are going to use a rectangle,
Is that orange or red?
orange,
Orange. See, I knew it.
Are you colorblind?
okay?
Yeah, he is.
Oh, really?
So-
It's like 12.
We're going to use the rectangle where the base of the rectangle is going to represent the velocity. The height of the rectangle is going to represent the mass. And so then what is this going to do for us then?
It looks kind of yellow on one side.
What's going to do for it? What's this going to do for us?
That looks green.
It is green.
Oh. See how the black makes it better somehow? Yeah.
Okay?
Drop some.
All right. You guys with me? Gentlemen, please stop talking. Thank you. So this is what we're going to employ. We're going to employ this idea that we're going to create, for individual objects, we're going to create rectangles, bars on a bar chart, where the base is the velocity, the height is the mass, and the area is going to equal the momentum of the individual objects. Is that cool? All right. You ready to rock?
Yeah.
All right, Annabelle, read me number one.
Wait for it.
In a freight yard, a train is being put together with cars.
Gentlemen, she's trying to read. Go ahead.
Empty freight car coasting at 10 meters per second strikes a loaded car that is stationary and the cars coupled together. Each of the cars has a mass of 3,000 kilograms when empty, and the loaded car contains 12,000 kilograms of canned soda, a year's supply for the physics class.
Okay, so here's our situation. So we have two carts here, okay? We have this empty car, it's cruising along, and it's gonna hit this car that has stuff in it. Cool? So this is the before picture. All right, the after picture says they hit and they couple together.
Is that one purple?
Yep.
Oh. I think I'm getting better. Really?
No,
I can tell.
That's,
The black helps.
not with the purple.
Okay.
I have no idea what
So,
it is.
within our system, we are considering the two carts, the full cart and the empty cart. Yeah, the purple doesn't look great.
I
Yeah, I
cannot
can't
read
really
that
read
at
it.
all.
Hurting my eyes.
All right, listen, we'll switch from the purple, settle down.
I can't even
Oh.
tell what it says.
It says full car.
My eye doctor needs to get his
Freaking out, settle down.
together and give me coffee. Like, it's not that big of a deal, bro.
Yeah, we have to do it this one.
That one's pink, right?
Yes.
No, it's orange.
I love the black.
Anyway, moving right along.
I think.
So, let's put the masses and the speeds on here. So this is the empty car, it's moving at 10 meters per second, and the mass is 3,000 kilograms. This one over here, it's moving at 0 meters per second, and it's 15,000 kilograms. Now, I know it says it's full of 12,000, but the car itself has mass, so the total is 15,000.
Agreed.
Got it? Well, so far so good? Now, the question is, after it hits and they couple together, how fast are they moving? That's the question. You with me? All right, so to do this, we're going to start on this side over here. We have one of our objects is moving. So watch. I'm going to represent its mass on here by drawing it thusly.
Thusly?
Got it? Can you see the green?
Yes.
It is, the mass is 3,000, so it's 3,000 tall. What about the orange one? How massive is this one?
15,000.
So how much longer should its mass axis be?
5 times.
5 times longer.
So like all the
1,
way down.
2, 3, 4, 5.
Yeah, I can only fit 4, but like you get
I got you. Which one of these is moving?
the green.
Both?
The green one? No, this is the before
Oh,
picture.
before.
How fast is it moving?
10 meters per second.
So 10. So what is the area then?
30,000?
30,000.
Yeah, I like kind of.
Whoa, what color is that?
That's red.
Red? That one's wrong.
That looks like a red and orange.
Okay. Now, let's move to the after side. What do we have going on over here? Do we still have the 3,000 car?
Yeah.
Sure. Do we still have the 15,000 car? We do, but now they are coupled together, true?
Yes.
So they are now moving at one speed.
Olivia.
Sure.
Oh, what happened?
Wow.
What? Fort Myers.
Now the question is, what speed are they moving?
1.67 meters per second.
But how could you figure that out? So
Make it a
here's the deal.
rectangle?
Because the momentum before has to equal the momentum after, that tells me that the area before has to equal the area after. So when I go to create this here,
We?
how tall is that rectangle? It's 18,000 tall
Okay, I need something.
because it's both objects.
Mm-hmm.
And what do we know the area has to be?
30,000.
Because the area equals the area. So the area is 30,000.
What color is that?
So the question is,
Red.
how fast, what does the width of our triangle have to be? If the height is 18,000 and the area is 30,000.
1.67.
1.67 is correct. So my point is that I want you to use this external structure to answer all the questions. Before side. Before, picture, momentum diagram, system, after, picture, momentum diagram.
Do we have to draw the system? too?
You're going to ask me, do I have to include all this? Literally all the pieces. What about on the assessment? Am I going to have to? Yes, all the pieces.
What if I can get the right answer without it?
If you can get the right answer without it, you still have to do it. Because you will be graded on your ability to demonstrate your knowledge using this external structure.
Do we have system circles to label it?
So I actually like the colors, okay? I actually really like the colors. So let's do some on a whiteboard today, see how it comes out, and then we'll go from there.